Now let's take a look at how we might compute the probability of independent events. And again, remember that independent events means that one outcome doesn't affect another outcome. So independent events. So we again just talked about the law of large numbers, and thanks to that we can look at calculations of probability. So remember, experimental probability is the number of times something occurs over the number of trials. So we saw this when we were looking at our stoplight example. At first I had 1 green out of 1, and that was day 1. On day 2 I had 1 green out of 2 days, etc., 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 and we settled into 35 greens out of 100. So that's going to be the probability that we're going to use. So let's look at a few of the rules of probability. The first is the value of a probability, and this seems pretty straightforward, but this is a great place where you might get some, say, multiple choice questions. If they tell me that the probability is, say, 1.35, so 135% chance, and we know that that is not the case because probability has to be between 0 and 1 inclusive, which means I can have a probability of 0. A probability of 0 means that the event will certainly not happen. I can have a probability of 1, which means it's 100% certain that the event will happen, and then it can be anything in between there. So again, I can't have a negative probability. I can't give 110%. I can't have a probability that is greater than 1. Keep in mind that we do write our probabilities as decimals, so if you're used to writing things as percents, just get used to writing them as decimals, because that's what we'll be doing this time around. So again, if I have a 50% chance of flipping heads, this is the proper notation. So I'm saying the probability, and then I will write this is the outcome, so the probability of heads, and then my probability, which is 0.5 or 50%. The next rule is very similar to rule 1, and that is the sum of the sample space. So we talked about the sample space being all of the outcomes that could occur. So in flipping a coin, I had heads was 50% and tails was 50%, and if I add up heads and tails, I get 1. Same thing for rolling a 1, 2, 3, 4, 5, 6. There is a 1/6 chance that I get a 1, 1/6 that I get a 2, 1/6 that I get a 3, etc., etc., etc. And if I add all of these values together, of course, I get 6/6, which is 1. Now you might be saying, well, hey, wait a minute, you just told me how to write it as a decimal. Why did I not write this one as a decimal? Well, 1/6 isn't pretty, right? As a decimal, it's a repeater. So when I'm doing calculations, it's okay to leave them in fraction form until I get to the end, and then at the end you would round it to a decimal, typically to 3 or 4 places. This brings us to the complement rule, and the complement of a probability is the probability of the event not happening. So there are different ways that we might write this, and we can see the different notations you might see. This is the one that is most commonly used, or that I've seen most often in my studies. So I'm saying the probability that A did not happen is equal to 1 minus the probability that it did happen. Okay, so using our stoplight example, I knew that the probability of green was 35 out of 100, and so that's 0.35. And so if I'm looking for the complement of that, or the probability that I did not get a green light when I got to the light, I would then take 1 minus 0.35, which would give me 0.65. So the probability of the light not being green is 65%. So what does this little box down here mean? Well, this is a Venn diagram, and we're going to be using those a lot. So this is a good intro. The box around the Venn diagram is super important because the box represents basically all items or elements in the sample space. So all elements in the sample space. So if I'm looking at the light, I either get a green, or I get a yellow, or I get a red. So if I'm looking at this particular example, and I'm looking at the probability of green or not green, then this would be green, and out here would be not green, aka yellow and red. And so that's all of this together inside the box. That always has to add to 1, again, because that's the whole sample space. All of the elements in the sample space, they add to 1. And again, that's why we can use that complement rule, because if this value is 0.35, then I know all of this out here together needs to be 0.65 for it to add to 1. This brings us to the concept of disjoint. And disjoint events are 2 events or more where they have no outcomes in common. So you might see a Venn diagram that looks like this, and this is significant because notice there's no overlap here in the middle. So that means whatever's in set A and whatever's in set B, whatever those are, they don't have any outcomes in common. Example, you can't be both a freshman and a sophomore in college. So let's think about what you can be in college. And we'll just stick with the basics. We won't get into all of the crazies. Let's just say you can be a freshman, or you can be a sophomore, or you can be a junior, or you can be a senior. And so notice that I've written a Venn diagram, but I don't have any circles in there because there are no values that aren't freshman, sophomore, junior, senior, and there's no overlap between them. If I want to find the probability of that one or another disjoint event occurs, I'm just going to add those together. So let's say the probability that I'm a freshman is 25%, sophomore is 20%, junior is 30%, and senior is 25%. If I want to know what's the probability that I choose a junior or a sophomore, then I would add junior plus sophomore, and my answer would be 0.5 or 50%. Same thing down here. I said, what's the probability of rolling a 4 or a 2? So first we have to determine, are these disjoint events? And yes, they are, because when I roll a die, I'm going to get either a 1 or a 2 or a 3 or a 4 or a 5 or a 6. I can't get both a 5 and a 6 in the same time. So I can draw a little Venn diagram like I did for my freshman, sophomore, junior, senior. And if I'm looking for a 4 or a 2, again, I'm taking 1/6 plus 1/6. And again, remember what I said before. It's okay to not turn these into decimals yet because we're in the middle of a question. So if I were to write this out, and here I forgot to talk about the fact that we're using an or is union. Union means 4 or 2, and that's exactly what union means. So the probability that I roll a 4 or a 2 is the addition of those probabilities, which is 1/6 plus 1/6, which is 2/6. I reduced that to 1/3, but notice my final answer I wrote as 0.333. So it's important that you do that, because if I would have rounded 1/6 and then added it to another rounded 1/6, I would not have gotten the same answer. 1/6 is 0.16 repeating. So let's say I rounded that to 0.167, and I rounded that again to 0.167, and now I add these together, and I don't get the same answer. I get 0.333. 3, 4, which seems insignificant, and yet it is significant. You want to be able to be as precise as possible. So we've just talked about 4 of the rules of probability, and before we continue on, I want to look at maybe some error analysis. So looking at these 2 statements, let's look at what's wrong with them. So the probability of a freshman, sophomore, junior, and senior are 0.25, 0.23, 0.22, and 0.20 respectively. So is that okay or not okay? Well, we know that these events are disjoint. You can't be both, right? Which means these 4 values, if I add them up, should add to 1. But unfortunately, there's something wrong because I don't get a sum of 1 when I add all of these together. So that is the error in my first statement. In my second statement, it says the probability of owning a smartphone is 0.5 or 50%, and the probability of owning a computer is 90%. And then I get a little bit worried because if I add 0.5 and 0.9, I get 1.4, and that's more than 1, and we said that wasn't okay. So is that wrong? Is there something wrong with the statement, or are these values wrong? So in this case, we know that this is absolutely fine because it's not disjoint. If I was looking up here, I can't be both a freshman and a sophomore, but I'm looking at statement 2. I personally own both a cell phone and a computer, and therefore these events are not disjoint. So they don't need to add to 1. There's some different rules for that we'll discuss when we get to chapter 13. So we've discussed addition. Now let's look at multiplication. And multiplication, again, this is for independent events. In chapter 13, we'll get into what happens when they're not independent, not disjoint, etc. But for 2 independent events, the probability that 2 events occur. So this is really, really important. A lot of people get confused. When do I add? When do I multiply? When I was adding, I only had 1 event with multiple desired outcomes. Only 1 event was happening. When I'm multiplying, I have 2 or more events. And so in this case, if I'm saying, what's the probability of rolling a 2 and a 4, that essentially means, what's the probability that I roll a 2? What's the probability that I roll a 4? Then I'm going to multiply them because that would be the probability that I have rolled a 2 and then rolled a 4. So again, let's look at this. So we know that there are 6 sides of a die. So the probability of rolling a 2 would be 1/6. The probability of rolling a 4 would be 1/6. Again, notice I'm not turning these into decimals till the end. Then I multiplied to get 1/36, and that is the point at which I would then turn it into a decimal. And then again, how many places do I round to? 3 or 4, but just pay attention to what's asked for in the question. So whether you're working in My Stat Lab or on an assessment, it should tell you how many places to go to. So here's some things to look out for. We know, again, or means we're adding probabilities, because again, this is just 1 event, multiple outcomes. If we have and, we're multiplying probabilities. And notice this is denoted as the intersection. This one was the union, and this is the intersection. So you may see those throughout our work. And again, for and, we have 2 events or more. If you see the word not, that's when we're looking at the complement of A. Remember, the complement was not A, and we're just going to subtract from 1. And at least we haven't looked at yet, but we will in just a moment. At least is the complement of none. So if I said the probability that I get at least 1, 2 when I'm choosing cards out of a deck It'd be 1 minus the probability that I didn't get any 2s. So in our next video, we're going to do some practice, and it will really help with this at least, because that's really the trickiest one.